Hello everyone. Welcome to Sweetie Speaks official YouTube channel. Today we are at day 44 of 111 days verification challenge. The skill set which we are focusing on right now is Verilog, and today we are going to focus on the topic which is Verilog ports. Let's see today's question. The first question is about different approaches of connecting ports in an hierarchical design. Explain these different approaches and also explain the pros and cons of each of these approach. Second question is, can there be full or partial no connects to a multi-bit port of a module during instantiation? There is a multi-bit port of a module. Is it possible that some of the ports are not connected, partial no connects, or all of the ports, full no connects, or all of the ports of this multi-port in a module are not connected? Is this possible? What happens to a logic after synthesis? Once you synthesize your design, which is RTL design, what happens to that logic that you need to explain? That is driving an unconnected output port which is left open during module instantiation. So you have an unconnected port. This port is left open. It is not connected to anything. So what will happen to this port when you synthesize your logic? How will it how will this port be seen in terms of hardware? Because once you synthesize you will get the hardware. So how this port is going to appear after synthesis? The next question is, what value is sampled by the logic from an input port that is left open? The previous question was about an output port which is left open. Now you have an input port which is left open. So what value is going to be sampled? The next question is, how is connectivity established in Verilog when connecting wires of different widths? Then, can you use a Verilog function to define width of a multi-bit port, wire or reg type? Is there any Verilog function which you can use to define the width? Width itself you want to define with that function. And this width can be for multi-bit port, wire or reg type. The next question is, create a bidirectional net with assignments influencing both source and destination. The next question is, what will happen if multiple procedural assignments are made to the same reg variable in an always block? There is a reg variable and you are making multiple procedural assignments to this reg variable in an always block. What will happen then? What value will this reg variable finally get? Then I have a code. You need to tell me what will be the result or output of this. I am having a module adder in which I am having reg A, B, C in and sum. I have a wire C out. In this module, I am instantiating one bit adder. I am calling that one bit adder FA1. And these are the ports of the adder. The first port was sum, the second was count, and then I have the first port was sum, the second was C out. Sorry, not count, C out. This C out. Then you have A, B, and C in. This is the instantiation of one bit adder. And then you are ending the module. I am giving one hint. The output port, this is the output port sum. This is the output port in your instance FA1 is connected to a reg variable sum in module adder. So this output port of your FA1 is connected to sum of your module. This is the hint. Now you need to tell what will be the result of this instantiation. This is the instantiation. Solve these questions today. Tomorrow I'll see you for day 45 challenge. Thank you and